So you are given in this example a certain population which has a mean mu and a standard deviation of sigma, right? And you are asked to test a claim about the population mean. Look at that, mu is greater. That's a claim. We have to test the claim that the population mean is greater than 18, and you are given the population standard deviation. So what we are doing in this hypothesis test, we are asked to test the hypothesis for one population mean when the sigma is known. And what we are going to do, we're going to use p-value approach. So just recall from my earlier videos that there are some steps available. There are actually 5 of them, and we are going to apply those steps one by one and see the complete hypothesis test. So let's see, what is the first step? Step 1. Let's recall what was the step 1. In the step 1, we check the basic requirement. We want to see whether the basic requirements are met or not, right? So recall from the earlier video, what was the basic requirement? Number 1 was you have to have a random sample, right? You have to have a random sample. And number two, either the population, either the sample size, either n was greater than or equal to 30, or the population was normally distributed. These are the two basic requirements we learned, right? So what I'm going to do now, I'm going to check whether these two basic requirements are met or not, right? Without these basic requirements are not met, we cannot start the hypothesis test. So let's see. Look at that. Suppose that the sampling is done randomly. So this is already there. We are already provided that the sampling is done randomly. Number 2, second requirement, n is greater than 30 or the population is normally distributed. Look at that n. Given n, look at that n. N is 50. Our sample size is 50, and definitely 50 is greater than 30. So we are good with that also. So both the basic requirements are met. So we can go ahead with the basic hypothesis test. Now we go to the step number 2. We are good with that. So what we do in step number 2, we write the null hypothesis, we write the alternative hypothesis, we decide what type of test it is, and we also decide on the significance level. Let's understand that. Let's write the claim here first. We have a claim. We have a claim that the population mean is greater than 18, right? Let's write its opposite. Its opposite. I hope you remember the method of writing, the process of writing this null and alternative hypothesis. What is the opposite of this one? Opposite of this claim will be mu is less than or equal to 18, right? Now one of these two statements is a null hypothesis and one of these is an alternative hypothesis. Recall from our earlier discussion, null hypothesis never contain this symbol, greater than symbol, never. So if this cannot be the null hypothesis, if this is not a null hypothesis, this should be an alternative hypothesis, mu greater than 18. And if this happens to be an alternative hypothesis, this one must be a null hypothesis. And what we are going to do, we are going to drop the equality, the less than symbol, and we're going to take the equality sign. Mu is equal to 18. So this is an alternative hypothesis and this is the null hypothesis. Now we have to decide what type of test is this. Note that what we note that the alternative hypothesis contain a greater than symbol. And I told you in an earlier video, if the alternative hypothesis contain a greater than symbol, then it's always a right tail test or upper tail test. So you will say as the H sub A contains a greater than symbol, so it implies that it's a right tail test. Right tail test. Finally, we have to, in this step, we have to decide the significance level. Our alpha value We are performing this hypothesis test at a significance level of 5% or 0.05. So we have completed the step number 2. We have our null hypothesis, we have our alternative hypothesis, we have decided what type of test it is, and we have decided what is the significance level. So now we are in step 3, and what we do in step number 3, we find the value of test statistic. And this is the step somehow the student think is more difficult, or I think it requires a little more attention, like there is a little calculation involved, and sometimes the student get confused. So be careful about that. So what we have to do, we have to find the value of the test statistic, and fortunately we have a formula for that. And what is the formula? Z equal to x bar minus mu divided by sigma over the square root of the sample size, right? That's a formula. We have all these values, right? What we're going to do, we're going to plug in these values here. Let's understand that. What is the sample mean? Look at the sample mean. It's 18.3. So it's 18.3 minus 18 divided by sigma. Sigma is 1.2. 1.2 divided by the square root of the sample size. What was the sample size? The sample size was 50. So the square root of 50, right? So if I write this in this way, that will be more easy for people to understand. 18.3 minus 18, it's turned out to be 0.3, and I keep it, change it, flip it, and I do this, multiplied by the square root of 50, and it's all divided by 1.2. That's an easier way to understand this computation. That's an easier way, right? So if you plug in these values in the calculator, you will come up with the value of the test statistics. So let me write Z, a test statistic, Z test statistics. The value comes out to be 1.77. I rounded to the 2 decimal places. Remember, I hope you remember that we always round the z-score or standardized score to the 2 decimal places, right? So this is the value of the test statistics, and this will help us in deciding the decision. It will help us in the decision criteria, what we have to do with the null hypothesis, right? So once we have done this, now we move into the step number 4. What is the step number 4? Let's see. What we do in step number 4, we find the p-value, right? So what we do, find p-value, the probability value, find the p-value. And in order to find the p-value, I have to draw a bell-shaped curve. That's how the bell-shaped curve looks like. Exactly in the middle, write the mean value, which is the standardized 1, 2, and a 3, a -1, a -2, and a -3. Now locate the value of the test statistic. Z test statistic is equal to 1.77. Now let's locate this value in this normal curve. P-value is 1.77. So 1.77 will be somewhere here, I think. Somewhere here. 1.77. This is 1.77. Now once you have located this value, you build a wall like this, right? A wall like this. You built a wall like this, and in this situation, the p-value is the area to the right of the test statistic. Remember, it's a right tail test, and when we have a right tail test, the p-value is actually the area to the right of the test statistic. So this area will be called as a p-value, which we are going to find, right? This is the value we are going to find, and this area we're going to find, and this area will represent the p-value. You have two options. You can use table or you can use technology to find the p-value. Let me use the technology for this purpose, and you can practice with the table. Okay, let's go to the Microsoft Excel and compute this area. So I'm already in Excel. So you go to the formulas, more function, statistical function, and you need to locate norm.s.tist. Norm.s.tist. That's the value. He's asking for the z-score. Z-score is our test statistics. It's 1.77, and he's asking, are you looking for the cumulative area to the left? From the left to all the way to the boundary line of the test statistics? The answer is yes. I'm looking for the same area. Now the answer comes out to be this one. But be careful. This is not the answer we're looking for. This area, remember, the table or the Excel always give you to the area to the left of the test statistics. But this is not the area we're looking for. We're looking for the area to the right of the test statistics. So what I'm going to do, I'm going to use a smart thinking. I'm going to subtract this area from 1. So I'm going to write an equal sign, and I'm asking, please subtract from 1 the content of this cell, right? Let me do it again. This is right, 1 minus this cell address, and I put, and this gives me this value. Let me round it to the 4 decimal places. So the area comes out to be 0.0384, 0.0384. Okay, so this is the p-value, 0.384. So we have our p-value. P-value is 0.0384. Now we do the step number. Now we do our last step. That is step number 5. And what we do in step number 5, we decide our test, right? And what we do, we have a p-value which is 0.0384, and we compare this value with alpha, which is 0.05, right? That's the p-value, 0.0384, and that's alpha. What we are going to do, we are going to compare these two values. That's the thing we are going to do. Like, let's see that. We'll compare number by number, 0, 0, 0, 3, and a 5. So this number is smaller than this number. So what we note that the p-value is less than alpha. And recall from my earlier discussion, if the p-value is less than alpha, we reject the null hypothesis. If p-value is low, H0 has to go. So what we do, we reject H sub A, right? Let's now interpret this result. How we're going to interpret this result? We reject the null hypothesis. Let's interpret that. So how we're going to interpret this? We're going to interpret that at 0.05, 5% significance level, we reject our null hypothesis, and as a result, we support alternative hypothesis. Our alternative, we reject null hypothesis and we support our alternative hypothesis. So at a 5% significance level, I hope you remember that whenever the p-value is less than alpha, we reject the H sub naught, right? So at a 5% significance level, we reject the null hypothesis, and whenever we reject the null hypothesis, as a result, we have enough data, we have enough evidence to support the alternative hypothesis. So I hope you understand all these 5 steps of hypothesis testing. Thanks for watching.